looked at back in 1999 on the day of the big tornado outbreak in Oklahoma, and looks like a hurricane. It has an eye and it has spiral bands. But it is not a hurricane, it's a tornado. And there's 500 meters. You can see the eye is about 300 or 400 meters across. It's a fairly substantial tornado. So you could stand in the middle of the tornado and just be fine. You probably look up and it would be hollow.
That's a great picture.
Thanks. And let's zoom in here a little bit. 100 meters. And we can see little ripples inside the wall of the tornado. So if you were standing inside the tornado, which I don't think you'd want to do, you could probably see ripples in the cloud. Wow. And these are probably centrifugal waves, some type of wave motion going on. There's the Doppler, by the way, and you can see the red going away, the purple coming towards. That's all noise, because there's nothing going on in there. So with this W-band radar, we can really map out the winds inside the tornado. I'll spare you showing any graphs right now.
Those waves that you're talking about,
Pardon?
The waves that you're just talking about on the inside of the tornado?
These are the waves in the tornado, yeah.
The waves that you're talking about?
Yeah, centrifugal waves.
Every violent tornado that I've witnessed firsthand, I've always seen the violent wave motion on the outside. Is that the same thing?
Yeah, yes. What are centrifugal waves? You probably don't want to know. But if you take a tornado vortex, and let's suppose you try to converge it just a little bit, you squeeze it, and let it go, it's going to oscillate. There's going to be a restoring force, just like throwing a cork in water, and it's going to go back and forth and back and forth and back and forth. Okay, some other nice pictures from the radar. This is a tornado. There's the tornado, but now we have what I call an umbilical cord. By the way, for perspective, we're really zoomed into the tornado. This is the hook echo in there. That's the hook. Wow. And there's the tornado. And that comes around for the rear flank gust front. This is what I call an umbilical cord. This is 1 or 2 pixels wide. So that represents about 10 or 20 meters across. If you've ever seen a tornado, you oftentimes see rain curtains coming around the tornado. So we believe this is a rain curtain. It's really, really thin. Why is this so? I don't know. Remember, numerical models can't even reproduce anything of that size. So we just have no theory at all. We've also looked at dust devils with this radar. I'm just going to show you that a dust devil looks just like a tornado. Reflectivity hull. In this particular dust devil that we saw in Texas, it's a Texas-sized dust devil. There are the Doppler velocities, red to green and blue, but within that we see a little green to yellow, green to yellow, green to yellow. Those represent multiple vortices. So we're actually able to see multiple vortices inside a dust devil. All right. Back to some pictures. Okay, this is from last year. I wasn't storm chasing. My wife and I were going from Norman to Boulder. We migrate there during the summer, and right along the way, there was this storm. Sometimes you get very lucky. This storm produced softball-sized hail, but no tornado. There's another bell-shaped storm. You see this very, very frequently. The eastern side of the updraft basin of supercell is frequently smooth. And the reason why it's smooth is you're taking air that's stable and you're lifting it. You're taking relatively cool air and lifting it so it looks stable.
Looks like a boot.
It looks like a boot.
Oh,
yeah.
Wow.
I got a kick out of that. You got a kick out of that. Mammatus, of course, are beautiful. They have nothing to do with severe weather. How many of you have ever seen the little book, the golden book, called Weather?
Yeah. It's got that in it.
It's got that in there, and they say that mammatus are associated with tornadoes. And I had this book when I was 6 years old. And when I got older, like a few years ago, they wrote me a letter asking me to review a new edition. And I told them the stuff about Mammatus was ridiculous. And the new edition came out, they left it in. They got what they paid for, though. Okay, more Exotica. In June of 1980, Fujita did an analysis of a supercell in Grand Island, Nebraska. And this is an old WSR-57 image. And even the WSR-57 radar, when the tornado got close enough, they could see the hole in the middle. So the stuff I showed you, not new. This has all been seen before. And there's the same echo, that's the rear flank gust front. But right along the other side, this is Fujita's analysis. We have a cyclonic tornado and an anticyclonic tornado. Cyclonic, anticyclonic tornado pair. People often ask, are there such things as anticyclonic tornadoes? And yes, they're very rare. Of all the anticyclonic tornadoes I've seen, and I've seen several, they always occur like this, in association with a cyclonic tornado. So here's some data we got with an X-band mobile radar that we got from the University of Massachusetts in Amherst. This is a polarimetric radar, and I'll talk a little bit about that in just a second. But I want you to see that here's the eye, the old eye from the cyclonic tornado. This is blockage from a telephone pole. And here we come back, and there's an anticyclonic hook. There's the notch. And just want to show you, there's the eye in the anticyclonic hook. And it looks just like what Fujita showed. And sure enough, we took a picture of an anticyclonic tornado right there. Really, really neat stuff. I didn't know this when it was happening. I mean, I just thought it was a regular tornado. Okay, what else have we learned from our W-band radar? These are images taken about every 15 seconds. So what we do is we just scan back and forth across the tornado like this. We're not taking volume scans. We're just taking sector scans at one low elevation angle. These are reflectivity. And I want you to see how, look at how different each image looks. And they're only 15 seconds apart. We get notches, two eyes, and then we get these notches again, and just tremendous variation. So you look at this and say, my God, if you really want to study a tornado, you have to have a really rapidly scanning radar if you want to see what's going on. Okay, again, I'll mention that again. Oh boy, I'm going to go over. I'll mention that a little bit. I better go a lot
Nobody's
faster
following
now.
you, so take as much time as you need.
Okay. Well, don't tell me that. I'll be here till midnight. You don't know me. The Greensburg, Kansas storm. How many of you remember the Greensburg, Kansas storm? Wiped out the town of Greensburg, Kansas. May 4th, 2007. It was the first night that we had the polarimetric X-band mobile radar that year with a new operating system. We went out. Major tornado. This is from Bob Fritchie. There's the tornado illuminated by lightning.